السلام عليكم ورحمة الله وبركاته. طبعا اليوم راح نرجع نكفي درسنا اللي هو بعنوان Quadratic Function. يمكن هاي الفقرة الأخيرة بالدرس. هذا الدرس الثاني طبعا. Our objective is to solve in R a given system of inequalities. You have to solve in R a given system of inequalities. This means that you have to find the set of values of x that satisfies a given system of inequalities. Example about system of inequalities. This is an example of a system of inequalities. A system of inequalities may consist of two inequalities or three inequalities or four inequalities, etc. Let us solve the first example here. A system of two inequalities. This is the first one. This is the second one. How we solve a system of inequalities? Briefly باختصار منحل الأولى منحل الثانية بعدين بنوجد الانترسكشن between the two solutions. The intersection, this means the common values between S1 and S2. First, let us solve the first inequality. The first inequality is x plus 2 is greater than 0. This means that x greater than minus 2. خلص السوليوشن الأول. أول solution, the solution of the first inequality. So x belongs to minus 2 plus infinity. This is S1. This is S1 is the solution of the first inequality. Now let us solve the second inequality. The second inequality is 2x minus 8 is less than 0. Then 2x is less than 8. Then x is less than 8 over 2 is 4. X less than 4 is the solution of the second inequality. This means that S2 is x belongs to minus infinity 4. The third step, this is the first step, solution of the first. The second step, you solve the second. The third step, you find the solution of the system. The solution of the system S is the intersection between the two sets S1 and S2. Is the intersection between the two solutions. This is the number line. We have to represent the solution S1 and S2 on this number line. First, we have to divide the number line to its units. 0, the origin, 1, 2, 3, 4. Also, we need minus 1, minus 2. We need minus 2, in fact. The first solution S1 is from minus 2 to plus infinity. The first solution is x greater than minus 2. Let us represent it. X greater than minus 2. This is minus 2. This is x greater than minus 2. All x's that are greater than minus 2 are accepted in this solution S1. Now, with respect to the second solution, x is less than 4. X less than 4, or x belongs from minus infinity to 4. So let us represent it by red. This is x less than 4. So the common region between the two sets is S, which is equal to S1 intersection S2. It is equal to minus 2, 4, which is the common region. The common values between the first solution and the second solution are the values that are belonging to this interval from minus 2 to 4. This region is the common region here from minus 2 to 4 in this. This is the interval. This is the solution of the system. Exercise. Solve in R each of the following system of inequalities. This is a system of inequality. A system of inequalities consists of two inequalities. This is the first one. This is the second one. The steps, you have to solve the first one and you find S1. You have to solve the second one and you have to find S2. Then after that you have to find S the solution of the system. First step, solve the first inequality. 3x minus 1 is greater than 2x plus 1. So 3x minus 2x is greater than 1 plus 1. So 3x minus 2x is x greater than 2. This is the solution of the first inequality. So S1 is x belongs to 2 plus infinity. Now the second step, you have to solve the second inequality. X squared minus 9 is less than 0. This is a quadratic inequality. You can solve it from the previous video. X squared minus 9 equal to 0. We are solving this inequality alone. X squared minus 9 less than 0. We solve it equal to 0 first. You can use the discriminant delta to find the roots, or you can solve it like this: x squared equal 9, so x equal plus or minus radical 9. It is equal to plus or minus 3. Okay. The system, the signs of x squared minus 9, minus 3 here, and plus 3 here. 0, 0. A is 1, positive, plus 1 is positive, so plus here and minus here. X squared minus 9 is less than 0, so the solution x, the solution S2 is x belongs to minus 3, 3, or x between minus 3 and 3 are the same. X belongs minus 3, 3 to the open interval minus 3, 3, or x between minus 3, 3 like this. This is the solution of the second inequality. Now the third step, we have to find the solution S of the system. It is equal to the intersection between S1 and S2, because S1 is a set and S2 is a set. The intersection between these two sets, the intersection between S1 and S2, is the solution of the system. So let us divide this number line to its units. Here, this is the origin O, 0, 1, 2, we need 3 also, minus 1, minus 2, here minus 3. In the first solution is S1. The first solution is S1, which is x greater than 2. X greater than 2, this is 2. This is the representation of the solution S1 on the number line. Again, we have to represent the solution S2 on the number line, x between minus 3 and 3. So its representation on the number line, this is minus 3, this is 3. This is the representation of the solution S2 on the number line. So the common part between these two intervals is between 2, 3. So S is equal to the interval 2, 3. Why the interval 2, 3? Because the two lines above each other, this line, look here, here in this region, in 2, 3, the two lines, this line and this line, are above each other. So in this interval, the two lines are above each other, so the intersection is 2, 3. The common values between S1 and S2 are all the values that are in the interval 2, 3. So this is the solution S of the system. The values of x that are in the interval 2, 3 satisfies the two inequalities simultaneously. This is the second exercise. Again, solve the system of inequality. We have to solve the first one, and we have to solve the second one, and finally we find S the solution of the system. 1. Let us solve 1. X squared plus 6x plus 5 less than or equal to 0. We solve it equal to 0 first. Solve it equal to 0. We have to solve it less than or equal to 0. First, we solve it equal to 0. So use discriminant delta is b squared minus 4ac. It is equal to 36 minus 4 times a1 times c5 is 20. So delta is equal to 16. It is positive. It admits this equation has two distinct real roots, x prime equal minus b minus radical delta over 2a. It is equal, minus b is minus 6, minus radical 16 is 4, over 2a, 2 times 1, 2. So minus 10 over 2 is minus 5. X second is minus b plus radical delta over 2a is equal, minus b is minus 6 plus 4 over 2 times 1, which is 2, is equal to minus 2 over 2 is minus 1. So we have to find the signs because we are solving the inequality. Minus 5 is less than minus 1. Here 0, 0. A is plus 1, positive, so here plus plus, here minus. We need from this inequality x squared plus 6x plus 5 less than or equal to 0. So the solution is x belongs to minus 5 minus 1 closed. Why closed? Because we have or equal. Minus 5 minus 1. Here, comma. Closed because less than or equal. Okay, or we can write it like this, between minus 5 and minus 1, and minus 1. This is S1. Let us solve the second inequality, which is S2. S2, the inequality is minus x squared minus 4x minus 7 is less than or equal to 0. Let's write it. Minus x squared minus 4x minus 7 is less than or equal to 0. Also, we have to solve, we are solving the second inequality, the second step. Solve it equal to 0. Minus x squared minus 4x minus 7 equal to 0. Delta is b squared minus 4ac. It is equal to minus 4 squared minus 4 times a minus 1 times c minus 7. This is equal to 16. Minus 4 times minus 1 times minus 7 minus 4 times 7, 28. This is equal to minus 12. Minus 12. 16 minus 28 is minus 12. Less than 0. Less than 0. So we have no real roots. So the sign the sign of this function, the sign of x squared minus 4x minus 7 is as a is minus 1, a equal minus 1, a equal minus 1 is less than 0. So this function minus x squared minus 4x minus 7 is less than or equal to 0 for all x in R. Less than 0. It is negative for all x in R. So what is the solution of x minus x squared minus 4x minus 7 less than or equal to 0? So the solution S2 is R. All the real numbers from minus infinity to plus infinity. We are saying minus x squared minus 4x minus 7 is less than or equal to 0 for all x in R. So what is the solution? The solution are the values of x that satisfies this inequality. So the solution S2 is minus infinity plus infinity all values of x, because it is negative for all values of x. So what are the values of x so that this is negative? So they are all the set of values of R, all the set of real numbers from minus infinity to plus infinity. Now the third step is to find S the solution of the system. We have to represent each one on the number line, each solution on the number line, in order to find the solution S of the system. This is a number line. This is the number line. Okay, that's it. Just divide the units on the number line. This is 0, 1, 2, 3, 4. Here need all the number line. Here we need minus 5 and minus 1. Okay, here minus 1, minus 2, minus 3, minus 4, minus 5. This is minus 5. This is minus 1. This is 1. This is minus 1. Okay, now let us represent the first solution. The first solution is x between minus 5 and minus 1. From minus 5, minus 1 closed. So this line is not dotted, it's complete line, because it is closed. Minus 5 to minus 1 here. This is the first solution, from minus 5 to minus 1, and closed on minus 5 and minus 1. The line is not, the vertical line is not dotted, complete line. Now the second one, let us represent this solution with the number line as 2 is all R. All R. Here, change the color. All R. This is S2. All R. So what is the intersection? What is the common region between these two solutions? S, which is equal to S1 intersection S2, is equal to minus 5 minus 1 closed, because minus 5 minus 1 is a part of this, of the second solution. The common region here هيك الخطين اجوا فوق بعض، الخطين اجوا فوق بعض in this region. And minus 5 belongs to the two sets, so it is in the intersection. Minus 1 belongs to the two sets, so it is in the intersection. So the solution S of the system is minus 5 minus 1. X belongs to minus 5 closed, minus 1 closed. This is the solution of the whole system. Now try to do this worksheet as a homework.